So big data. So what is data and what is big data? We'll see that. So there is no distinguishing factor as to who needs to learn big data and data science, whether it is an engineer or a auditor or a medical professional. Everybody nowadays, we need to know what is big data and what is data science, because it is going to rule the world in the days to come. Take my word. And I challenge this fact actually. It is going to be pervasive in all walks of life, whether you are going to order your grocery, whether somebody is going to supply you water, or somebody is going to determine you the bandwidth in your network, or somebody is going to determine how you are going to plan your automobile service network, or to design a rocket algorithm. Everywhere you are going to have this big data and data science and artificial intelligence. Okay, so it's good that anyone in this crowd would be benefiting by these topics. Okay. Let me start with the data. Data basically treated in a singular, it's called a datum, and of course in a plural. You can nowadays call it data for singular or plural. Now in the modern English allows any kind of pronunciation and any kind of interpretation, as you know, right? So if it is treated as a mass noun, it is any sequence of one or more symbols given meaning to specific acts of interpretation. This is what the Wikipedia says, right? When you are in the traffic light signal, when it turns from red to green, that is a data for you to go and move forward, right? So like that data could be anything, any symbol or any sign, which will have its own interpretation so that people can take actions on it, okay? What is a digital data? Digital data is data that is represented using the binary number system of ones and zeros as opposed to analog representation. I don't think I need to explain what is an analog and what is a discrete, because you're all engineers and you would be fresh with this knowledge and education about analog and digital representation, right? So anything which is represented in the form of zeros and ones, that is the only thing that any computer will understand. So that is a digital data in a binary system. And any data represented in a digital form is called a digital data, okay? Okay, I think I do have some network issue. So just I'm pausing the video for a while. Is it okay? So after the presentations are over, I can again switch back and come on screen. Okay. So what is a unit that is used to measure data? It is a bit, which is 0 or 1. And when you call a byte, it is a set of 8 bits together. And when you call kilobyte, it is 2 power 10, which is 1024, 1024 bytes, or for brevity, you can assume it is 1000 bytes to take an analogy of kilo, right? And when it's say megabyte, it's 2 power 20. And similarly, gigabyte, terabyte, petabyte, exabyte, zettabyte, and yottabyte. I'm not sure how many of these bytes you have heard before, particularly yottabyte and zettabyte, and something more, which is not listed here, which is called bronchobyte, okay? It's a further 2 power 100, I think, no, 2 power 90 bytes, okay? So the units keep going up and up. And you need to know these things if you're going to work in a big data or in a data science. And I'm sure most of us today would have internet access either through your data card or through your broadband connection at home, right? So you get all those packages with the 80 Mbps, 100 Mbps data, etc. So do you know what is that Mbps at all there? Is it megabits or megabytes? So the clarification is like this. When you say capital M, it is mega. When you say small b, b as in boy, small b is a bit, megabits per second. When you say capital B, MB, it's a megabytes. And most of the data plan that we have either in the mobile smartphone or in a broadband connection, it is a bits. So it is 100 megabits per second or 80 megabits per second, which means it is 10 megabytes per second only, right? So beware of that when you are calculating the time to download a particular movie from this internet site. Looking at the size of the file and size of this and the speed of your connection, you can determine how much time it's going to take. So that is what it is about the units of data. So what is a big data? Is it a gigabyte of data or terabyte of data? Yeah, I have a big, really a big set of data set, which is something like 2 terabytes. Do I call it a big data? No, no, anything above 500 gigabytes itself is a big data because it's too huge to process. Is it a big data? So we don't know. I said there is no industry standard stipulated definition of a big data. However, there is a consensus when you say a big data. So what is a big data? Let us see. What is that consensus among the practitioners in the industry? So, so big data means anything in the range of petabyte and above, which means 2 power 50, 2 power 50 bytes and above is termed as a big data. And anything in the range of terabytes are not actually big data. We would have been dealing with, I mean, when we learned computer science, even a gigabyte was a big thing and terabyte was something we only heard in the notebooks and other things. But today, you do have external hard disks, which you buy for 2 terabytes easily, right? And you have loads of pictures and movies that you would have stored in it, right? So terabyte is not something not known to us. It's very familiar, but probably we would not have heard about petabyte in our personal data usage. However, in our work environment or in a research environment, the college, etc., yeah, we would have encountered the petabyte of data. Okay, but I would have been happier if anyone in this crowd or any of the audience here would have handled the data sets in the size of petadata. Okay, but you would, if not today, you will handle such a data in the days to come. Okay, so when we say big data, anything in the range of petabyte and above is called as a big data. Okay, okay, so what are the types of data? Data can be, it can be measurements or facts or observations, etc. What's the temperature today in Chennai or in Hyderabad or in Mumbai? That's a measurement, right? That's a data, right? What's a fact? What's the stock market, the last closing stocks yesterday? That's the data, right? And the data could be structured. It could be comprised of clearly defined data types whose pattern makes them easily usable. For those who are not from the computer background, when you say data type, data is, I mean, they're categorized or classified as different types. Something like a numeric data, if if it contains numbers, it's a character data. If it contains characters, and even in the numeric data, you have whether it's an integer data or a floating point, which is equivalent to real time data, real data, not real time, real data set in the mathematical linear algebra convention. Okay, so like that, you do have data types as pointers or strings, characters, etc., etc. Okay, don't bother too much about it. When you really work on these things, you will get to know what a data type is. Okay, uh, the point here is when it's a structured data, you will be able to understand what is the meaning of a particular data is. Okay, so for example, if you have a vehicle, the vehicle license plate AP01 YY9530 of your license plate of your vehicle is structured data, because you know what is the AP. It's not a random alphabet. It is the nomenclature or the convention for denoting the state where the registration happened. A means Andhra Pradesh, right? So the remaining two numbers are the RTO office from where you got the license. Then you can get the serial number, right? The remaining two character or one character prefix followed by the 4-digit number. So you know by looking at it, you know what piece of the data that you see and what it refers to. Okay, and in a phone number +91 followed by 1 2 3 4 5 6 etc. You know the +91 is a country code for India, and the remaining 10 digits are the numbers of the phone number, right? And if it is 0 1 1 followed by 8 digits, you know it's 0 1 1 is for a Delhi STD code, and the remaining numbers are the phone numbers. Like that, this data is structured. You know what it means. Okay, so that's called a structured data. What do you mean by unstructured data then? Well, everything else, right? It's comprised of the data that is usually not easily searchable, including the formats like an audio file or a video file or a social media postings. For example, you have a movie, you have a song in your phone or your iPod or any of your device, and is it possible to go to the particular word or particular stanza of the particular song? It's very difficult, right? Or if you have recorded a speech of somebody, is it easy to go and locate a particular paragraph or anything? It's not very easy. So it is not well structured. It is just a stream of data. Whereas a structured data have clear partition as to what means and where it starts and where it ends, right? So that is the difference between a structured data and an unstructured data. And you do have, normally we, in the digital world, we only have zeros and ones. We don't have anything in between. But of course, in the case of data types, we do have something called structured, unstructured, and something in between called semi-structured. Okay, semi-structured data is something which maintains an internal tags and markings that identifies separate data elements, which enables information grouping and hierarchies. It's a big sentence, but when I give you an example, you will understand what each of these words means. Okay, so semi-structured is basically something in between, neither structured fully nor fully unstructured. Some portions or some part of the data is structured and some part is not structured. So that is called a semi-structured data. Um, Here is an example chart which talks about what is structured data and an unstructured data. We'll talk about the characteristics of each of these things. If it is structured data, it's predefined data model and usually text only or easy to search kind of thing, or usually number only correct kind of thing. Okay. And if it's unstructured, it's a no predefined data model, or it could be text, images, sounds, videos, or anything for that matter. And it is difficult to search. It is difficult. It is not impossible to search. It is difficult to search. Okay. I'll tell you why I'm making this statement. Okay. And structured data resides typically in a relational databases, data warehouse in a computer environment. And in the unstructured data resides in applications and NoSQL databases and data warehouses and data lakes. What's a data warehouse? What's a data lake? Right? I mean, these terminologies are really funny. You have a cloud environment, you have a data lake kind of thing. Better to learn what these terminologies are and try to understand. Okay. And how are they generated? Typically human or machine generated structured data, and unstructured data are also generated by the humans or machines. And the examples and application, you could see that here. If you see the examples, a date or a phone number or a Aadhaar number, credit card number, they are all structured data. And whereas the unstructured data is a typical text file or a reports or email messages, images, surveillance images, etc. What are the applications that do process these kind of data? If it's a structured data, any of the computer applications like CRM systems or ERP or any reservation systems, etc. Whereas unstructured data, it could be anything, word processing, PowerPoint presentation contains unstructured data, email clients, all these things are examples. Okay. What is a big data then? It's both structured and unstructured data is what big data comprises of. Okay. Okay. Now, what's the big deal about big data and why do we need to know about it? I'll cover in the next few slides. What are the challenges? Why do we need to know about it, about the nuances of our big data? So how do we convert the data to information? Information is data made useful, interpreted and applied to produce understanding. Most of the computer science students, they know what is the complete life cycle, what is the data, what is the information, what is knowledge, etc. Right? You would have learned in your college curriculum. And data processing is the process of converting raw data into usable and in a desired form. So what is the sequence? What is the pattern it happens? You first have the source of data, and then you collect the data from various sources, and then you store the data temporarily, and then you transmit the data to the place where it needs to be processed. And after it gets processed, you'll get useful output. Okay. So what are the sources of data today? Few years back, we were not having this much of data sources, digital data sources when I say that, right? We did have radar imagery and radar data, weather data, airline data. They were all producing huge volume of data. At that point in time, probably we did not call them as big data, but yes, they were all big data. They are all big data. But in the last one decade, with the advent of the smartphones and the communication between almost every other individual in this world amongst themselves, you have a plethora of sources. You just take a picture and then send it, share with the other person. You send a text message, you send a video message, you send an audio message, you download pictures. So the generation of data has become digital data has become really easy, and that has really exploded in magnitudes, the source of such a data. Okay. So not only that, um, now we also have a technology where we are able to capture this data and store it for further processing and usage. We'll see in some of the upcoming slides what are the sources and how do we process, etc. Okay. So here is a chart which gives various ways in which we collect data. There are two similar charts. There is nothing different. There's only the representations are different. Okay. Here you would be able to identify most of the symbols or icons that are shown here. The first one, the two human images are something like a chats and other things. And you have Wi-Fi data and you have a radar picture showing the how do you collect the various terrestrial and spatial data. And you have a email symbol where you are going to collect so much of data from email. You have the settings data where you get the data from various machinery, whether it's automobile or computer system, whether web server log, etc. You have a camera to give the pictorial data, and you have music, audio systems, you have smartphones, you have the other plethora of data sources from the internet, etc. Okay. So the same thing is indicated here. The sources of the data are from the computers and various other equipments and machineries, including non-digital non-digital machines, which has digital sensors like the aircraft or the car or a train or any other systems. Okay, and you have smartphones and you have other various organizations which are going to create so much of data, right? Whether organization or the governmental data centers, all these things contribute to the growth and accumulation of data. Then what's happening in the big data trends actually? So we have various technology to process and handle this kind of data. Some of the popular technologies that are in vogue are listed here. You have something called a Hive, we have Cassandra data sources, and you have something called Spark and Hadoop. Hadoop is particularly which the technology which really gave a boost to the big data processing, and that is now being superseded by the Spark technology. So when you talk about big data, please remember the terms Hadoop and Spark. Okay, Spark is something in-memory data processing, which is capable of processing high volume of data, and Hadoop is something a technology which allows even a normal conventional commodity hardware and software to participate in big data processing and handling. And you also have a HBase, which is a columnar database from Apache, and MongoDB. You would have heard about the MongoDB with unstructured data processing database system. Okay. Talk about big data analytics. You do have this life cycle. You have weblog and streaming of data and social network giving a lot of data, and you have transactional databases at the bottom of the slide, which are the sources of the data, and they get consumed or processed by the Hadoop systems or Hadoop distributed file system, which is also called HDFS, which is basically from the Google file system. They were the people who first designed this Google file system and then gave it to the public as an open source technology, which is later renamed as Hadoop. Okay, that helps to store and process a high volume of data across distributed locations, providing not only redundancy but also quick access to the data source which is in need. Okay, then also you remember the word map produce. That's again a typical slang which is used when you talk about the big data and Hadoop and kind of analytics work, uh, which gets processed and sorted out. Then you get it stored into the enterprise data warehouses after the pre-processing of the data. And once the data is analyzed using the data analysis technologies, you get very good insight about the underlying volume of data which could be used in the reporting BI tools or the big data tools. Okay. So it's a typical life cycle. So there are challenges because of the volume of data. How do you make sure that you are able to collect the source of data without any interruption or without any flaw? Okay. And incorrect data is as good as not having a data, right? So you need to have the right data and make sure the data is valid. So because of the volume, how are you going to store it? How are you going to move from one place to another place for processing? And how are you going to analyze such a volume of data, right? So these are all the inherent challenges when we talk about big data. Okay. So what we normally do is you have an application and you have data from different sources. You move the floppy drives or a hard disk or download from the internet and then get the data and can then process the data and then find insights from the data. This is okay as long as the data volume or data size is something like a few kilobytes or few megabytes, etc. What would happen if there's a question from Somebody wants me to repeat once again and technology. What was that? Is that the recent message? Anyway, I'll pass this question from Debit Kumar. Okay, I'll answer your question a little later at the end of it. Okay. Resuming back, I was just talking about the chat message I got in the Zoom meeting. Okay. So we were talking about how do we handle the volume of data. If it's a megabytes or kilobytes, we can move the data to the application and the application can process. When we are talking about the petabytes of data, I have around say 2 petabytes of data and I need to process it. So the choice is a, do I move the data to the place where I need to process, or do I move the computing program to the place where the data resides? The answer would be it is easy to move the application which is going to process the data, or the computer program which is going to process the data to the location of the data rather than moving the data to the location where it needs to be processed. This is an important concept that you need to know when you talk about big data. This is called a data locality. When you say data locality, the data resides locally where where it was sourced or generated. Okay, and the computing program or the computing black box is going to move towards the location of the data and gets the data processed and take only the insights and then move to the location where it needs to be consumed eventually. Okay, so remember the source of data and the high volume of data, and it is better to move the program to the location of the data rather than moving the petabytes of data to the location of the program or the application. This is what I want you to remember when you talk about data processing. Okay, and the data gets processed using the latest technologies, and then you get better insights which will help you to take business decisions about the using the big data. Okay, so what is the realm of big data? Are you able to see the screen, the picture? You have a various, again, the sources and other data generators, the different locations, the video, images, documents, events, etc. Okay, so this is what is the realm of big data. So it's as confusing as voluminous as the picture looks like. Okay, it's real, an ocean of in the field of data science. Okay, talking about big data. Okay, why do we need to know what is so important? This is something I picked up from an published article in the internet. How big data and AI algorithms are helping to combat or even find the COVID infection amongst the patients. Okay, radiological big data and AI algorithms which are under development and evaluation, that is going to help the radiologist to quickly look at the MRI image of a patient or a suspected person's lung image, and looking at it instead of a human making interpretation by looking at the image, the AI data will be able to give a more precise information whether the person is infected with the COVID or not, as well as what is the level of infection. Okay, so that is one use case of big data. How about in the financial industry? The financial field is profoundly engaged with the calculation of big data events, right? If you look at the around the world, so much of genuine and fraudulent transactions that do happen every millisecond in the world, right? So they're all data, big data, high volume data. So you collect all those things and process them in order to make sure that whether the transaction is a genuine transaction or an incorrect transaction. Okay, so I'll try to give an example about this in a while. So not only in healthcare and finance, what about in agriculture? Because now we do get a lot of news about the protest that's happening in the capital city related to agriculture reforms, right? So let's talk about what is the use case in agriculture area. So it's again, if you look at it as late as January 7th, this article was published. Okay, so all these things are trending topics. How big data is being used on date in various fields. Okay, how you can use big data? It is going to help you to meet the food demand in any country, and it's going to help in optimizing the usage of pesticides. Okay, and it's also handy to manage the farm equipment, where to deploy at what time of the day, what year of the day. Okay, and yield prediction because of this weather conditions and the other conditions, how much of yield I can expect. Okay, talk about it, none of these things are hypothetical, they are all real life, and it's not just only in the research level. I have seen people, okay, who have got experience in all these things. Okay, talking about the financial usage of the big data, I'll give you an example. uh, you get a transaction alert if it's not genuine. For example, you are going to use your Visa card today, right? Somewhere in Hyderabad, you are going to use the Visa card using your credit card. You are going to pay for a purchase in a store, okay? And immediately after that, within another 5 minutes, the same card is being used in, say, Nigeria for a transaction using that card. So this big data algorithm immediately on getting this transaction request from Nigeria for the same card, it has to decide whether the transaction is genuine or fraudulent. You have hundreds and millions of customer data performing transaction using the credit card. So with such a volume of data, this computer system need to determine whether this transaction is genuine or not. With Because of the technologies of the big data, it is possible today to immediately detect how can a transaction happen within a 5-minute interval between Hyderabad and Nigeria using the same credit card. So it is suspiciously, it's very suspicious and suspected to be a fraudulent transaction, right? So it's going to immediately alert. It is going to send you an OTP message or a telephone SMS message. There's a transaction being attempted. Is it genuine or not? Please confirm. So this is how the finance industry make use of the big data to determine a fraudulent credit card transaction. I'm giving this example because it's a very popular use case when you are going to learn about the big data. Not only this, if you are going to apply for a loan, the big data helps in determining whether this particular candidate who is applying for a loan is genuine candidate. Will he be paying back? Is his payment repayment plan are genuine? All those things are calculated by various parameters. What is the person's age? What is his credit card history? What is the business he's venturing in? Where does he live? How much money he's asking for? What are the sources of payment to pay back? All those things are determined in a probably few minutes or few days. If it's a loan transaction, probably it can take an hour or so to give a feedback about the possibility or probability of the person being genuine to pay back. Whereas if you're talking about a credit card transaction, you need to decide in milliseconds, right? You do not have time to decide within 1 hour or anything, right? Because if, for example, you may be a business person, you may genuinely travel to Nigeria to negotiate a business deal. But if you have not performed any transaction using the same card in Hyderabad a few minutes back, probably that would be deemed as a genuine transaction. But also not only that, it would immediately check, did you book any airline ticket using the credit card or any other similar credit card? Because nowadays, because of the common PAN number and all, they are able to track every other transaction you have made. So it is going to track, okay, this person has genuinely has flown from India to overseas abroad, and he's likely to be in Nigeria at this point in time. So we don't need to suspect this transaction. We need to allow the person to perform a transaction. You would be paying in you want to buy a no coat because of the bad weather in Nigeria, and if you're not able to use your credit card genuinely, that is also not a good thing, right? So you should not decline a genuine transaction. At the same time, you should not entertain a fraudulent transaction. So all these things are determined using the big data technology in the finance industry. And in the agriculture industry, I do have a friend personally known to me. He is a consultant and he's having a big farm where he has deployed the IoT sensors in his farm, which will determine the moisture level of the soil, and it will determine how much of water need to be supplied to the various plants. Because supplying too much of water is also going to create a problem. Supplying less water is also going to create a problem. He was talking about various sensors. He will talk about, even give you indication about the quantity of various salts in the soil, and accordingly he is going to determine the usage of the various fertilizers and the mix and proportion, and which particular location where you need to have a concentrated fertilizer mix and where you need to have a very diluted fertilizer mix, etc., etc. So this is going to improve the agricultural production, and it's going to reduce the wastage, and it's going to increase the yield, which means it's going to help improve the economy of the individual and the country and for all of us, right? So that is where the big data and the technologies that are going to be pervasive every walk of life. It's going to help us to have a better lifestyle in the days to come. Okay, talking having talked much about big data, let me talk about data science. Data science, again, is nothing new. This has been there for ages, okay, not today. I mean, for thousands of years data science has been existing, but the nomenclature data science came into common usage in the recent past, okay. So Even our ancestors, they have so much of prediction only based on data science, but they did not call it a data science, or we did not call it a data science. But now we are giving it a name because you have so much of data. There's a discipline of science in itself to analyze the various insight that we could get from the data. What is data science? It's a practice of transforming existing data into meaningful insight. We saw this definition earlier also. How do you use data to understand through exploration and analysis? And looking at this picture, you can easily see there is some pattern. There's some low numbers in the January, and it is going up and again coming down in October and tapering down in December, right? Something 16.6, 20, and during April, May, it's going up to 30 and again coming down. But looking at it, it's very easy. You can easily tell whether it's a salary of an individual 16 lakhs per month or 16,000 per month or 16 billion deficit. With our common sense, we easily, most of us can easily make it out. This could be a temperature data of a particular city, right? Where because particularly a city in the northern hemisphere, because you see a very low values in the January, December, and a very high values during April, May, June. That is a summer in the northern hemisphere. So this could be a temperature in centigrade, not even Fahrenheit, right? So these are some of the common things, but I have deliberately avoided giving new units in the y-axis. But this is an example of how a data and how one can visualize by looking at the data. Okay, so it's up to anybody to make a guess what data it is. Okay. So this is how you do an exploratory data analysis and find what data it is, what it is representing, and what are the hidden facts behind it. And uncovering insights, patterns, and trends that are hidden behind the data. And again, talking about the same temperature and weather, I'm going to talk about it. You must have heard about these terminologies, El Nino and La Nina. If not, just go through the slides. El Nino is basically a phenomenon of event, which is the warming of the Pacific waters, which occurs at intervals of say 2 to 7 years, okay, in the Pacific. What would happen? Why is it so important? Because of that, what is happening is the warm currents flowing towards the east displace the cooler currents in the Oceania, and because of which the rainfall occurs over central and eastern Pacific, but it will result in drought in Indonesia and Australia. So when you observe El Nino phenomenon in a particular year, you can for sure expect a drought in Australia and Indonesia. So if it's going to be a drought, you can plan your various other corrective actions in terms of agriculture or even in other aspects of life. Okay. And so what about La Nina? It's again a similar weather phenomenon, a cold episode that usually follows the warm equatorial ridge cools between the coasts of South America and Oceania. What is the impact? You have currents contributing to form a warm pool of Oceania, increase rainfall in Asia and Australia, and lower the temperature on American coast and increase the aridity. Okay, so this is how we have been using data, even though we have not been calling it a data science or big data, but yes, we have been using this kind of data in the weather prediction and forecasting using supercomputers in the erstwhile days. At temperature rise or rain, as temperature rise, rainfall patterns change around the world, and monsoon in India is often weak or weaker during El Nino if it happens. Okay, what is the economic impact? You'll have monsoon rains are critical. You know, it's critical for India's economy, and around 70% of the India's farms depend on rainfall. So if the rainfall is going to be bad, you have to expect a weak economy growth or weak agricultural growth. Okay, that's how you correlate the data and its interpretation. So what's so big deal about it? We know all these things. Why are we talking about this in a big data and data science course today in this wonderful Saturday evening? Those days we were in need of supercomputers to process such a huge volume of data. But today we don't need a supercomputer. A simple desktop computer in your college laboratory can participate in a network of a big data processing environment. Okay, and you don't need a proprietary algorithm, as even an open source algorithm can help you to predict and process the data and predict findings from this data. How can you benefit by that? I'll come to that. Okay, so you should know what is in it for you, right? Okay, so if we dwell into why and how beyond what is happening, okay, that is where we need to know data science and we need to have big data technologies. And this helps in transforming a data into knowledge that can guide decisions and provides techniques and methods to make sense out of data. So it's basically a concept to unify statistics, data analysis, machine learning, and the related methods in order to understand and analyze actual phenomena. That's what the Wikipedia states. Okay. So if you want to pursue in the direction of data science and big data, you need to necessarily learn mathematics, particularly statistics and linear algebra, and some of the machine learning algorithms. And do you need to know about computer? Yes, it's a must. You need to know computer programming to some extent if you want to continue or pursue your career in data science or big data. And what computer technology, what kind of things you need to learn? Something which is very common and predominant in big data technology is the language Python and language R. More importantly, Python and R helps a lot in statistical analysis, whereas Python helps both in statistical analysis as well as in developing applications using UA and all. I'm not saying R does not support, but Python is more common. Okay. So if you think of any career in data science and big data, try to pick up skills in linear algebra and statistics and also Python and R. So what is data? It's data is not equal to knowledge today. We say data plus data scientists call a knowledge. This is one way of calling why data and data scientists are important. Okay. So how does it coexist? You have a domain expertise and you need to have a computer science and you need to have mathematics and statistics. All put together at the center is the data science, right? So, I mean, if you don't know how to interpret a data by looking at a medical image, the computer can say, hey, here are some spots. But if you don't know what that spots are, only a doctor can understand, right? By looking at an MRI of a lung, he can predict, oh, okay, these spots are indicative of some possible COVID infection, right? And by looking at some of the temperature or sensor data from automobile, only in a mechanical engineer will be able to understand, oh, okay, this is because of this. The belt is warning out or the spark plug is not firing, the timing belt is wrong, right? So the domain expertise is necessary. So good news for the mechanical engineers is, I mean, your domain expertise, the mechanical field in all manufacturing in the various areas is going to come handy when you couple your knowledge along with the data science and machine learning or artificial intelligence. What about the computer science guys? Well, we have all industries to support, right? So you don't need to worry about it. Even though you may not have respective industry knowledge, you have any, we can walk into any industry, whether it's healthcare industry or agriculture industry or a media industry or finance or automobile, where you can help them to design algorithms and implement machine learning algorithms to help them make good decisions. Okay, so the crowd here, both mechanical engineers and computer science engineers, you will be benefited if you learn data science and big data. Okay, what are the examples? Artificial intelligence, I'll talk about a minute, about briefly. It's the ability of a digital computer or computer controlled robot to perform tasks commonly associated with intelligent beings, right? That's the Britannica's way of defining it. And it's a simulation of human intelligence processes by machines, especially the computer systems. That's another way of defining it. Okay, whatever we could think of, whatever the human brain is capable of distinguishing and finding similarities and differences, if the computer is able to do that, then that's called artificial intelligence. What's the machine learning? It's the ability, or it's a software which gives the ability for a computer system to learn from looking at the data. Okay, so it's an application of artificial intelligence or a subset of artificial intelligence. Okay, and it helps in, it basically focuses on developing computer programs to access and assess data and to find meaning from the data. Machine learning algorithms are often categorized in supervised and unsupervised. I'll talk about it, what it is, to give a good, with a good example here. So data science applies machine learning to create real world applications and products. Okay, so this is a high level life cycle. You have domain knowledge, you need to have communication to move data, and you have a way to present the data, and you have to do a data mining and then find the meaning and give visualizations to data so that the business person can understand what the particular data is and how to make business decision using the data. So for all these things, data science is a center focal point. Okay, everything else revolves around it. Okay, how data aids, it helps not only to know what happened and why it happened, what will happen, and it will help in decision support system and decision automation. So you have a raw data collected from the world or the global universe around you, and that is processed and it's cleaned, and then you do an exploration and then come up with the good machine learning models and algorithms which will help you to make decisions. Okay, so you analyze the past historical data And medical researchers might study the records of patients who suffer from particular disease to determine what factors have led to the illness or death. That thereby they are able to come up with an easy diagnosis of the ailments or the illness. Okay, and you have streaming data analytics. For example, you have a Twitter data or you have Facebook data, anything which is data stream, which is coming continuously. There's nothing like a start stop at a particular time frame, right? So you continuously get that all those things, and then you process those things, and then use the streaming data to make predictions. And you have weather forecast data, and you also have a prescriptive data analytics. Okay, what is supervised data? It is based on, you know, if this is what you are giving a supervising the machine learning algorithm to make a judgment. If it's unsupervised, you are not having any clue about the data. The machine has to learn by itself. Okay, so the basically you have something, two things called unsupervised learning and supervised learning. And in unsupervised learning, one of the popular discipline is clustering, whereas in supervised learning you have classification and regression. And what is regression? You would have studied in your both the mechanical engineers and computer science engineers, you would have studied, right? Using regression analysis. Based on the data trend, you form a regression formula and you'll be able to predict when the new data come in, right? So discrete data, when you're able to predict, it's called as regression. Something like you have a draw a graph and then you predict a line for a new data point. What is the if a value of independent variable, which is typically x, what is the value of the dependent variable, typically y. Okay, this is called regression. And unsupervised learning is something like completely without any supervision, you are going to make a judgment or understanding about it. So one of the basic disciplines are clustering and classification. Here I want to give this example because it's easy to understand. You have a set of 6 objects, and if you have to cluster in different groups, how are you going to cluster? There are different ways, right? Some people may cluster based on the shape. All the spherical objects are one group and non-spherical objects are another group. Somebody may cluster based on color, right? All those in red are one group, all those in orange and all those in blue are another group. Somebody may make another clustering, right? What are edible things, what are non-edible things. So we don't have anything. So, but you tell a computer, okay, I show this picture of an apple and say this is an apple, and show a picture of orange and say this is also this is a fruit. So when I say apple is a fruit and then orange is a fruit, it is going to say, okay, if it is a fruit, it is edible. Those kind of learnings the machine will do by itself because the way you give them a data. Okay, that's called supervised and unsupervised learning examples. Okay, so it's used in digital marketing, it's used in predictive analytics, and it's used in various pricing strategy. So I do have few slides, but before that I just wanted to only talk about some of the examples. For example, today nowadays when you are going to make a purchase in an online, when you are going to buy an airline ticket, you are going to buy a ticket and you are going to browse through that. You are finding it's a ticket from Hyderabad to Mumbai is costing something like say 7,000 rupees one way. Okay, and you decide not to go ahead with it, and after some time you're seeing another offer somewhere else. So the moment you're going to visit the same airline site same day in a quick succession, the computer will predict, okay, you are interested in the ticket. So it's what was shown as 7,000, now it will become 7,150, marginal increase. So they are able to trap your IP address from where you are trying to check the airline pricing. And if you are going to show interest in buying it, it's going to automatically jack up the prices. So this is one example of how artificial intelligence, machine learning, and big data are made to use. And some of the people who have that Google Analytics in smartphone, etc., I have seen an example. A friend was talking to me about it. Hey, I have a candidate by name Rajagopal going to come for an interview this afternoon. Within a minute, in his screen, you had a pop-up about Rajagopal in his LinkedIn. You want to know about Rajagopal? Because the smartphone is sensible enough to recognize your voice, recognize the name, and is going to immediately pick up the names relevant to that. Because he said it is for an interview, it is relating to the LinkedIn site, and then passing it to LinkedIn, and they are going to pop up messages using that. So this is how the artificial intelligence, machine learning, big data, and data science is going to help you in the, or help you or bother you either way. Okay, it's going to really play a role in your day-to-day lives. And we are actually working for developing an algorithm application where it's going to predict the cryptocurrency values in different exchanges across the world. How do we leverage the data and how it's going to change every millisecond? How are you going to buy and sell decisions are going to be made? Okay, so like that, if you know machine learning algorithms, if you know how to handle big data, you can make your own share trading decision to buy or sell by choosing a particular product. Okay, you can see what is happening in Apple. You can predict whether it's going to go up or go down in the next 10 days. Then that will help you to buy or sell. Try it out in small volumes in your own interest. And if it is profitable, you can develop a package, or you can even become a agent to take commission by selling and buying, right? Become a share broker. So this is how your machine learning or data science and big data knowledge is going to help you on a day-to-day life. And if you're going to work in automotive industries, you can, if you're in the R&D, you can find the data, how a driver is driving pattern in the day, in the night, and skidding pattern in a rainy season, on a sunny day, how it is happening, how the engine is performing, is the engine heating up, what is the performance, what is the mileage. You can get a plethora of data, big data, and then you can analyze and you can help in fine tuning your engine design, okay? All those things. So there is no limit where you can use big data or data science or artificial intelligence. And if you really want to know more about it, join a course with Virginia Tech and learn the trade of tricks of the trade. So I would like to stop at this stage for want of time. And as I told you, big data topic is very big, and data science topic is also really in ocean, and one can talk for days and months together.